So, tere päivästä, good afternoon to you all. I come from Tampere University of Technology, which is abbreviated TUT, as is the Tallinn University of Technology. So I came from TUT and now I am at TUT, feels at home. I'm gonna do my talk on the renovation or demolition from a more or less theoretical point of view. And I'm going to do that based on my own research, as well as the research of other people. I'll present you some evidence, but on other points you'll just have to take my word. And if you have any questions during the lecture, please feel free to ask them, or you can also reach me for a conversation afterwards. Here's the fundamental question of the lecture, or even the day. And I chose this image because it quite nicely underlines the very relative and subjective nature of this question. What we see as worthy to keep varies not only between individuals, but also in time. This is a Helsinki neighborhood that is today very precious, high prices, but in the 60s the arguments for its demolition are awfully similar that we use today. Energy and plumbing. The same goes for the Finnish National Gallery Atheneum building. In the 50s they listed almost all imaginable reasons to support its demolition. It was too expensive to repair, the plot was too valuable for this building, it didn't fit the needs of the user, it wasn't fire safe, so they said, it had structural deficiencies and even bad architecture. Could you believe it? So today we see a phenomenon of value inversion where we think differently. We can conceptualize the building stock like this. We have the existing stock that consists of buildings that are normally in use, but also there's a part that is vacant or underutilized. You always need some vacancy in the housing market. If you didn't have any empty flats or empty premises, no one could ever move. So you need some vacancy, but a part of the vacancy is long-term and problematic. And we can think that a part of this stock is towards the demolished stock, so it's going to be in risk of being demolished. So we can call this part of the stock obsolete, which means outdated in a sense. And we often think that since buildings are completed, they are bound to move towards the problematically vacant stock and eventually to the demolished stock. But buildings are not people or biological creatures, so buildings don't have a biological maximum life. If they are maintained, they could last virtually forever. So this kind of development is really not inevitable at all. What's more, buildings are often demolished directly from use, so they never enter the vacancy phase. This dynamic is also affected by new construction, and we can ask how it really affects demolition. So we are inclined to think that we need to build new buildings to replace the obsolete ones. But also if we do excessive new construction, more that is really needed, that could push some existing buildings that could still be usable to the demolished stock. And in a more sustainable system, this path would not be linear, but buildings would return from obsolescence to use, and as a result, less would be demolished and less would be built. And the demolished buildings could act as sources of recycled raw materials for new buildings as well as repairing buildings. To understand better why and how buildings fall into obsolescence, we can look at this theoretical model, so how buildings become outdated. Here we can see two axes. One of them distinguishes between behavioral factors and physical factors, and the other one between endogenous factors, so factors related to the property itself, and exogenous factors, factors that relate to surrounding conditions, not the building itself. So as a result, we have this fourfold table, and you can see that the actual physical building represents just one corner, and there are three corners that are not related to the building itself. So you have the physical environment, the site, for example. Then you have the use and management culture of the building. If it's not maintained well, it will deteriorate more quickly. And you even have the societal conditions, which encompasses, for example, expectations towards buildings. So we can measure some qualities of buildings objectively, like the energy use, how much energy a building uses. But if that amount of energy is a lot or a little, if it's good or bad, is a question of your expectations. And for example, the norms we have for new construction, they would belong to this corner. They also inform your expectations for older buildings as well. In the end, researchers have found that the behavioral factors are decisive for the demolition of buildings, and not the physical ones, such as material or age. For instance, if we look at the average ages of demolished buildings in Finland, we can notice that residential buildings are on average almost 2 decades younger at the time of demolition than residential buildings. So this year, an average demolished block of flats in Finland will be about 60 years old, whereas an average demolished office building will be about 40 years old. And there's no reason to believe that the structures of these two building types would be so different that the average age, the difference in the average age, could be explained with that. So instead, you can explain it with the function and the ownership. The office building is likely owned by a real estate company, so it's in the hands of one owner, whereas in the block of flats, all the residents own the apartments, so you have like 40 owners or so. It's much easier for the company to do the decision to demolish than for a community of 40 people to agree on an issue like that. And also, it depends on the owner's expectations, because the real estate company expects to maximize profit, whereas the residents are more interested in the residential service the building provides them, not necessarily on the value of the plot or how to maximize it, for example. Here's another example that looks at demolished buildings from a different angle. So here you can see demolished buildings built from different building materials originating from different decades. And the way you read this figure is that, let's look at wooden buildings, so the red line here. During the 2000s, 5% of the stock of wooden buildings before the 1920s were demolished. That were still standing in year 2000. So when it comes to wooden buildings, the line is as you would expect it to be. The older the stock is, a larger proportion is demolished. But if you look at other materials, such as concrete or bricks, it's different. So you can see here in the 40s stock, for instance, that the demolition rate is higher for brick and concrete buildings than for wooden buildings. So if you would believe that the durability of the building material would be very decisive for the survival of buildings, you would be quite puzzled How can this be? And if we bring the building type, so the function of the building, into this picture, we can see great differences between different building types. I chose here just two examples of two extremes, detached houses and warehouses. So you can see that regardless of the material, the demolition rate of the detached houses is around the same. But the difference is enormous if you compare it to the warehouses. And even though there's a greater distribution here, you can see that the rates are incredibly higher. So the building type is actually more decisive than the building material or the building age. Researchers in the Netherlands, they found that demolished buildings often do not represent the physically worst part of the stock, but an acclaimed bad condition is a socially acceptable reason for demolition. It's a more acceptable reason than, for example, bad business or bad residents in the case of rental apartments. Another popular argument besides condition is the energy use of buildings. And therefore, I want to walk you through this theoretical comparison of carbon emissions. Here on the x-axis, we have the time from this point, some quarter of a century. And on the y-axis, we have the CO2 emissions. In this first scenario, we have the continued use of buildings. Every year, a given amount of emission originates from heating the existing building stock. And let's compare that with a scenario where the existing buildings would be replaced with new ones. So you immediately notice here in the beginning this carbon spike. That originates from constructing the building, manufacturing the building material, the concrete, for instance. So if we assume that new buildings are more energy efficient, they use less energy than the old buildings, it starts to accumulate from here. But because of the carbon spike in the beginning, it'll take more than 20 years to actually use less energy than if we would just have kept using the old buildings. Building even more energy efficient buildings, like passive standard buildings, is not a very good answer either, because you get a higher carbon spike. You need more insulation materials. But the buildings are more efficient during the use phase, so maybe in 2 or 3 decades you will use less energy. Of course, we must acknowledge that we need to repair the existing buildings as well in order for them to last. So this causes a similar carbon spike as new construction. It's just smaller because the majority of the building already exists. And here too, if you increase the energy efficiency of the existing buildings, the carbon spike will respectively be higher. So here we have all the scenarios, and now we're wondering what's the one that we should choose. And to make that decision, I have to inform you about one more thing, because this one, of course, is a theoretical examination. So we assume the new buildings are more energy efficient than the old ones. But are they? And to do this, I will need to use this energy efficiency class rating. I suppose you are all familiar with this. A is better and G is worse. So according to calculation, the newer buildings are more energy efficient than the older ones. Something like this. A colleague of mine at BuildIT Tampere did a research on the actual energy use And guess what? The newer buildings were not better than the older ones. Almost all blocks of flats in this study, more than 700 of them, they belong to the energy efficiency class F, which is not very good. And this has been observed internationally in other countries as well, and it's been explained with human behavior. So, depending on user behavior, you can actually observe a 5-fold difference in energy use in a similar building. So apparently, people who live in less energy efficient houses are more keen to save energy because it pays back in their energy bill, whereas people who live in more energy efficient houses, they might think that they've already done their bit buying that nice and efficient house, and there's no need to pay attention to energy consumption anymore. This is one explanation. So I return to these scenarios and how they might look like if we take the real energy consumption into account, maybe something like this. So if new buildings in fact use the same energy as the old ones, the carbon spike, it will never become compensated. What actually matters is speed. So even though you'd believe that the new buildings, they use less energy, we don't have time to wait many decades for them to do so. The climate scientists, they say that we need to cut emissions now, by 2020 if possible. And as far as I've understood, it is not okay to increase the emissions in short term to have them reduced in long term. They need to be cut now. So from the climate point of view, the choice between life cycle extension and demolition is quite clear. So in the end, it's not very surprising that we should be very careful to not accidentally promote policies that don't help us to achieve what we would want to achieve. Researchers have said that combining energy conservation targets with demolition programs has obvious shortcomings, and policies may unfortunately create regimes that exacerbate demolition. And they also point out that buildings should not be judged based on their current performance only, but also the potential that they withhold. That would be smart renovation. And since this seminar focuses on panel buildings, I will now use this opportunity to show some of our research how to unveil the potential of panel buildings. We had a research project that looked at how panel buildings could accommodate for different demographic groups. And the first thing that we had to do was to study what kind of flats they contain. Because the Finnish panel buildings, they are not standardized. On the lunch break, I learned that the Estonian panel buildings, their plans are standardized. So in your research, you could skip this phase. But we had to do it because the Finnish ones are not standardized. So we had a sample of 9,000 flats, and we were able to identify 10 basic flat types that occur in these buildings. And they have some small internal variation, but in the end there were only 18 variants of these basic flat types that covered 80% of all Finnish flats between 1960 and 1980s. But if the plans are standardized, you know how the flats are, so there's no need to do this. Since elderly people are a major resident group in these buildings and they don't serve their needs very well, we wanted to show how they could serve them better. And for that purpose, we chose the 6 most common flat types. that cover 2/3 of the era's flats. My colleague, Tapio Kaasalainen, developed this 4-level model. And this model was applied to all of the 6 flat types. So this model starts with little things, such as rearranging the furniture and removing the thresholds that the resident can do or have done by him or herself, and that doesn't cost a lot. And in the other end, you have extensive renovation of the bathroom, the balcony, and external structures, which the housing cooperative must be involved in. The resident can decide on that by themselves, and the costs are larger. And then you have 2 intermediate levels between those 2. So this 4-level model essentially encompasses measures for improving the mobile accessibility of these flats to help the elderly people to live there for a longer time. And the final solution should always be customized for the individual and the flat. So you're not supposed to take standardized measures. That would be like repeating the first mistake. But you're supposed to customize for the needs of the resident. And you can pick measures from different levels. Here we have some customization examples that belong to the 4th level, so the heaviest alternatives. The first one is for, I go back, one more. So the first one is for an independent wheelchair user and a spouse who is not a wheelchair user. The second one is for a spouse that uses a walking aid or is visually impaired. And the last one is for a bedbound wheelchair user with a spouse that assists or an assistant that visits. Besides being customizable for the resident, this model is also customizable for the flat. So here we have some flats that represent a certain flat type, but the details are always different. It's the measures are not exactly the same. So we tested that this model can also be applied to flats that differ from each other a little bit. So in the end, here you can see the 6 most common flat types transformed to serve the needs of senior citizens better. Another demographic group that we wanted to look into was families, because these buildings, they were originally built for families, but the flats are, in today's standards, quite small. So the families are now in the minority. And this part of the work was done by a student of mine, Hanna Akren. She studied how you could improve the functionality of the flat without physically extending it. So you sort of extend it within its perimeter. By moving the kitchen away from one of the rooms into a kitchen living room, you get an extra bedroom here. So doing this to these flat types, you can sort of enlarge them with one room, even though you have the same square meters. And of course, this is a heavy change that must be done in parallel with plumbing renovation. You can't just go and do it by yourself, but it has to happen in the whole building at the same time. So then we also studied which flats are located next to each other. And this allowed us to study the possibility to combine the flats in both horizontal and vertical direction, if even larger flats are needed for families. This is just one example. There are many more of them. And we also studied where the internal staircase could be placed in these flats so that you could create 2-floor maisonette type apartments for families. And this illustration shows that type of flats in the top of the building, where actually the smallest apartments were removed from here. so that you could create a roof terrace for these maisonettes to act as their yard. And on the bottom floor, you could give these kinds of homes a private garden of their own. And here it's also been suggested that some office or working facilities could be combined with living. If you have two-floor homes, the ground floor, here you could also have some private businesses, and then you would live on top of the business. As the ground floor often contains only storage spaces and is quite close to the outside, so this is a good opportunity to sort of open it up for the neighborhood in a nice way. So this was my brief presentation, and I will sum up a little bit. To remember from my presentation, first of all, human factors are decisive. Demolition is not physically inevitable, and the construction material has actually quite little influence. Life cycle extension is more climate friendly than new construction in most cases, and buildings have potential for adaptations, and this potential can be explored in a systematic way, and that's what I would recommend you to do in your studies. So for the time being, I thank you for your attention. Suur aitäh, and if you have any questions, comments, I would be happy to hear them.
Thank you. And as usual, we will start with public questions. Does anybody have a question? Then just raise your hand. Or if not, then I will start with the iPad. First, if the idea is that buildings, when properly I will take the second question because I'm sorry, I don't understand the first one. You had an example of a flat redesign where separated was, where a kitchen was moved to a living room. How will you get the pipes to the living room?
It requires a full plumbing renovation, so it's only reasonable to do this if you're going to have a plumbing renovation in the building anyway. If it's just being repaired, there's no reason to do this. It'll be too expensive. And of course, it also requires that a similar modification is done on multiple levels. Or that's the easiest way to have the corridor for the plumbing.
Then the second one, do you think if a person would like to combine the flats and renovate them, would it cost more or less to the person than buying a new one?
Well, usually the older dwellings are more affordable than the newer ones. So the whole point of doing this kind of research is to find ways to families to get more affordable dwellings. But of course, it always depends on the location and the case. So it's not possible to answer in a definitive way.
Then question about architects. Architects usually want to design mainly from the start. How it is in Finland, for example. Like, are there architects interested in redesigning existing buildings?
Well, I think this is something that's happening all over Europe now. The training of architects and also engineers has been oriented towards new construction very strongly, and this is something we actually need to change, because in future, when we have a stock that renews 1% each year, we have 99% of the existing stock each year. Most of your job opportunities, or at least many of them, are going to be in existing buildings. So I still have in my students, I teach architectural renovation at UT Tampere, I have this mindset that some of them are not interested in renovation, but we try to affect this, influence this.
Try to make this more interesting.
Yeah.
One more question. You mentioned that pulling down the building, it's not dependent on the building material or the age of the building that much. But what about building systems? They tend to age, like kind of age more quickly, or you should change or renew them more often.
So, like
ventilation, for example, plumbing,
yeah.
Electricity, perhaps.
So we have like some structures that are very long lasting, like the frame of the building, which usually is protected from weather, could last for 200 years or even more. And then you have these, like the systems that have a shorter life, but often they are also not changed because they would actually break down, but because people expect more from those systems. So I think it sort of follows a similar pattern, at least to some extent, that the expectations are more decisive than the actual functioning of the system.
Could we say then that if we, you showed us before the graphs, and if we take an old building that we do not renovate, that we don't renovate at all, do we then use, should there be more initial steps in between if we compare them with deeply renovated buildings, or just build new, if we compare them with completely new buildings?
Yeah, I think you get the best result by regular maintenance, so that you never let the building to deteriorate. And the worst condition the building is in, the higher your carbon spike for renovating it is going to be. But nevertheless, it's always smaller than with new construction.
Yeah, thank you.
I also have one question.
Okay.
So, well, I think we should demolish all the Soviet houses, because it's, for my opinion, it's pointless to renovate them, and we should actually use media to motivate people not to waste money on renovating their own apartment when it's actually necessary to tear down the whole building.
Could you elaborate a bit more why it's necessary to
Because
demolish?
they were built for 50 years only, but now it's, some of them are older than 60. And I know that concrete has its own age, that when the concrete is like beginning to go to dust, like after some kind of years. And anyway, I know that people want to renovate it and they think it's cheaper, but yeah, if they were meant for 50 years, then why we should live there 100 years?
This is the argument you hear often in Finland as well, that the panel buildings, they were built for 30 years or 40 years. But then when somebody looked into it, there was actually no evidence that would show that this is the case. And I think it's not reasonable to too much think about what the original builders meant. I mean, we have the situation now, so we have to deal with it. And as for the deterioration of the concrete, I don't know if there's somebody who is more involved with Estonian buildings, because I haven't been, so I wouldn't know, but there are certain deterioration mechanisms for concrete. So I don't know if you could elaborate which mechanisms turn the buildings into dust.
Do you know who built all the Soviet houses? Like who are the people?
The workers?
Yeah, but what workers? Just workers, you think? Anyway, it doesn't matter. So anyway, they didn't. If you look at the houses, if you live in one of those houses, you see that they're not properly built, and the walls are not straight, and everything is like a little bit behind our time.
But that's your expectations again, not necessarily potential of the building. I have a building that doesn't have straight walls.
But if we
I don't mind.
Tear down, maybe we should start from the oldest Soviet houses. But if we tear down the buildings, then we can use the material, like you said in this conference, to reuse the materials, and we have also the land that used to have the old Soviet house and build like energy sufficient houses. Maybe even use sunlight for energy.
The bad news is, look and correct me if I'm wrong, but if you use the recycled aggregate concrete for the new buildings, you will have a higher carbon spike than if you would use virgin concrete. This is my understanding of the issue, if you want to have the same quality of concrete. So from the climate point of view, the recycled aggregate concrete is actually not necessarily always so good, and the renovation is, from the climate point of view, a better option. But as it comes to the condition of the buildings, I would recommend you to make condition investigations. So with the condition investigation, you can actually determine the quality of the concrete and the state of the concrete. I think
we're going to have a complete discussion because I don't agree with you.
Yeah, I think we can continue our argument later on, perhaps. But now I would like to thank Satu on behalf of the BuildIT team. And again, with a hammer, I hope that you
thank you very much. Well done.